Welcome back to Catamaran Conversations, a deep dive into the world of catamaran design with Phil Berman, founder of Balance Catamarans, Patrick Shaughnessy, president of the esteemed Far Yacht Design, and sailing writer and journalist Herb McCormick. You are watching the 5th of 8 episodes in this series. If you've just joined us for the first time, best you click over to episode 1, Designing a Catamaran from the Inside Out. Find previous episodes linked in the card above or in the description below. Now, let's pick up the conversation as we look at VPPs and Bruce numbers.
In our last installment, we talked about dagger boards, and this time we're going to talk about something a little bit more esoteric, VPPs and Bruce numbers. These are the ways that performance is justified by equations. At least I think that's what it is, but Patrick, why don't you take me through exactly what are Bruce numbers and VPPs?
So when you're designing a boat, you have to use some tools to estimate the performance of the boat. And a VPP, or a velocity performance prediction, is a tool that takes a description of your boat and simulates the performance based on the input you provided. And so as a designer, when we're making choices about a boat, we add some sail area, run a VPP, see how the performance reflects that change and compare it to a base value. And we sort of optimize along a path until we get a boat that performs the way we want or our client wants. And a VPP has become a complicated tool. There are only a few commercially available tools that are trusted in the marine industry. And the very high-end designers have their own versions of those VPPs that are based on the research work we've been able to accomplish in America's Cup or Volvo races. And so the testing we do improves those tools all the time until we have a tool that we believe in. And we use that tool to then estimate the performance of a boat. A person in the marketplace, a potential client for a boat, is trying to compare boats. They look to simplified measures to try to draw a comparison between a boat. And so a Bruce number is a number, I believe, created by Edmund Bruce, who incidentally also created the Bruce anchor. So he's touched a lot of what we're doing in various parts of the world. And maybe the use of the actual Bruce number was popularized by Bruce Roberts, another yacht designer. But what it is it's a fairly simplistic equation, which I guess we're going to show on the screen. But what it takes is your boat's sail area, and for the sail area it uses 100% fore triangle in the mainsail area, and it square roots that, and then it divides it by your displacement to the cube root, and that produces a number, and that number is intended to give you an indication of how much sail area you have for your displacement, so some measure of the performance or the displacement or the riding moment of the boat. The problem that a consumer has when they're trying to draw this simple comparison is that one, it's only as good as the input, which is usually the truth of about every tool. Output is as good as input is good, but it's also very simplified. It doesn't reflect your real sail carrying capacity. It doesn't reflect, even on a monohull, it doesn't reflect the beam of the boat, the form stability of the hull shape. In a catamaran, it's a little bit worse than that because it doesn't reflect how far apart your hulls are. And so it doesn't do a great job of measuring your sail carrying capability. In any case, that's what a very simplistic method for people to try to draw comparisons between boats.
Power to weight ratio, really.
Yeah.
It's a simple power to weight ratio.
But maybe a little bit more than that. If you're a consumer trying to use a Bruce number to draw a comparison between boats, you also have to use information that was provided to you. And sail area is a relatively easy thing to measure. Displacement can come in many shapes and sizes. And so in a yacht design sense, we think about displacement as light ship, usually half load, which is half tanks and half gear and stuff, or we think of full load, the boat fully loaded. And obviously those displacements can vary quite a bit. And sometimes promotional material also can use even lighter displacements than that if you're trying to spin a bit of a yarn. So it puts the consumer in a little bit of a difficult position trying to draw comparisons. To try to improve a simplistic model, you can also, what's used as a real performance index, which is a slightly more complicated equation that also includes the height of the center of effort of the sail plan. So it starts to better account for the where the force is being applied to the sail plan, but this RPI still doesn't account for the distance between your hulls or form stability of the hull. So it's still a very simplistic measure. So
isn't it meant to be sort of like a safety number on top of the Bruce number?
well, it's I guess because you're including a height of your center of effort, you're including how much easier it is to tip one boat over than another.
Right.
But because it's still avoiding some of the inherent truths about the boat, it doesn't do a great job of capturing that. I guess the larger topic is, as a consumer, how do you draw comparisons between boats when you're shopping? And then further than that, as an owner, how do you know how to operate your boat correctly? And so both of those things kind of lead you toward the more complicated thing, which is VPPs, and how do they work and what do they tell you? How do you really learn about a boat?
Yeah, like Bruce numbers, I don't take them very seriously. There are some social media influencers that say this is like super important somehow, but I mean, a Bruce number not only doesn't measure the catamaran's beam, but the Bruce number is the same if the catamaran's going backwards or forwards.
Or even sideways.
Or even sideways.
Yeah.
Or even sideways, right? So it doesn't take into account the shape of the hulls, the beam of the boat, any of those things which are so important, or the drag of the appendages. So that's why these VPPs are what we turn to. And I don't know which one you guys use. So Anton uses the VPP from the Wolfson unit at the University of Southampton in the UK, their division of aeronautic and marine engineering. But Anton's partner Sean has told me, he says there's like 4 respected VPPs, 4 or 5. Or...
Yeah, approximately. And we have that same VPP, and we also use a completely proprietary VPP. Each designer ultimately has to have a tool that they understand, and by understanding it, can trust it. And so all of these tools have weaknesses, and the more you further your understanding, the better you're able to use it, just like any tool in your arsenal, really.
We were running VPPs on one of our boats, like for upwind, and I was noticing, compared to another catamaran, and we were faster in all conditions except upwind and really heavy air. And I said, well, why is that? And Sean said, well, because he's probably got a higher heeling angle than I put in. So they put in a 4.5 heeling angle. That's what they think is the right heeling angle. So that obviously impacts, because you're reefing the boat, our boat sooner, say, than the one that was in the other VPP.
This is an artificial, what he's saying is you can place an artificial limit on heel that once the boat is increasing in wind speed, say it approaches this heeling limit, and then it forces it into reefing, where otherwise the boat may have continued to flatten or reef at some different place in the VPP. So you can limit many things in this tool to force it to do specific things that you think are desirable. So in this case, these guys are saying this is a desirable characteristic for the boat, so we're going to cap heel here, force the sail handling to work around that.
To work around that measure. I mean, the point you made about displacements is really important, and then the input that you put in, because, well, I remember some years ago there was some website that was supposedly like a catamaran site that measured performance. I don't know whether they used Bruce numbers or what they did. And because I was selling a lot of used catamarans, I got to sail on pretty much all of them. And there was one figure that I saw for a 60-foot European cat, I won't say the name, and they had this boat going like 14 knots, and I'd sailed on that boat, and nobody could get that boat over 10 knots under the best circumstances, And so I said, okay, well, something's wrong here. When talking with Anton, and we've kind of talk a lot about, well, people want to get this comparative thing. In Europe, most of the manufacturers, if they produce information, they produce it at Lightship. Okay, well, Lightship is not a boat that anybody's ever launched. Nobody's launched. Have you ever launched a Lightship boat? Well, maybe a racing boat.
Yeah, I mean, in a racing boat sense, you do. But even so, when we run VPPs for a racing boat, it doesn't make sense to run the VPP in a Lightship configuration, because when you're racing, you still have crew and sails and gear and fluids, and so there still is half load. There's load coming onto the boat, and so the bigger thing is it can be disingenuous to represent the boat as something that's nothing like the way you would use it.
Yeah. And so we've arrived at what we like to do now is we know what our boats weigh at launch, give or take, like, their weight in the factory. So we have a good range of what the equipped boat is. And everybody orders an equipped boat. So we call it launch weight. So we provide what we call an average launch weight, and we run our polars right in the middle of that number now, because that way, that approaches probably like what I would call a coastal cruising mode, right? But if somebody wanted to get polars at full load displacement, leaving Cape Town, 4 or 5 crew, food, full fuel, water, the whole 9 yards, that's obviously a slightly different, right? Would yield different results in a polar.
Yeah, and I guess the two parts of understanding boat performance are sort of alluding to is, one is I'm shopping and I'm trying to cross shop some things and compare them. And so you're looking for ways to try to compare them, which is very difficult. The other thing is you've already purchased a boat and now you're trying to understand how to use it. The VPP is a tool that should help you learn what your boat wants to do. And so your boat wants to be sailed certain ways, and that information is buried there. And sometimes it's not hard to read the tea leaves there and see what it means. But there's a lot of information about your boat contained in the VPP that ultimately it behooves you to learn how to use this VPP tool and to make it part of your sailing so that you understand what should happen, what your boat really wants to do.
Brings us to polars, right? So
Yeah.
explain exactly what polars are.
So polar is a term loosely applied to a portion of the VPP, which is sort of a graphic representation of the boat's performance. And so what a polar table is it's sort of a wind rose, and around that wind rose at specific wind speeds, the VPP can draw a curve that says this is your velocity at that wind speed. So at 6 knots, at this angle you go this fast, at this angle this fast, and you draw a curve around it. So you look at this polar table, because it's circular, it shows these curves representing the boat's velocity at different wind speeds.
Yeah.
And a couple of things to sort of further complicate that, the VPP is producing an estimate of your performance in these conditions, but it has to make a lot of assumptions. Besides the assumptions we made inputting the data, describing the hull shape and the sail plan and all these things, it also assumes a bunch of other things that are largely unobtainable. It assumes that your, bottom condition is X, and it assumes that your sails are perfect, and it assumes that your use of the sails is perfect, and all of these things are perfect.
Your skipper is perfect.
Everything is perfect, and so once you gain some experience with a boat, you learn what percentage of polar speeds you're able to achieve. And the reason that's important is, even in the most simplistic of routing, if I say, I want to go over there and it's 100 miles that way, even if it's straight and the wind was constant and all these things, if you use your VPP information, it would say, I'm going to get there in this many hours. And the reality is, if you sailed at 65% of your polar speed, which is your typical average you achieve for whatever reason, then you're going to arrive at a much different time. And that happens, people are trying to estimate tidal gate entries or try to arrive somewhere before sunset. So all of these things are important about learning to use your boat correctly. So understanding how the VPP predicts the performance, understanding what percentage of that performance you can achieve, and working down that path.
Yeah. I mean, I have to say, me personally, look, I look at them when we're designing the boats, but I go down, I look at the boat, and then I go, okay, I have a pretty good idea of how it's going to sail. But I do know that there is a real difference between a boat that's loaded to bear leaving Cape Town, right, and a boat that's stripped. And you know what I'm saying? I remember once going to New Zealand, and I was doing a Thursday night race, and I got invited to be on this monohull. And before the race, these guys are just hauling sails off the boat and stuffing them on the docks, and I thought, well, God, it's just the weight of all those sails, right? But you can't really do that on a cruising boat. You can't, you can't be taking all this stuff off your boat.
Yeah, you need all that stuff.
You need all that stuff, and everybody equips their boat differently. So I think, as he said, there are limitations, but I think by using an average of launch weight, that gives the VPPs that we'll be providing our customers a much better idea of what I would call coastal cruising mode, in a way. Something that one of my customers said to me was he was thinking about getting a carbon mast for his boat. And he said, well, that carbon mast is going to cost me this much money. And how much weight is that going to save me, Phil? And I said, well, it's not really going to save you that much weight. And he said, well, you know what? I think when I get to the Caribbean, I'm just going to run around with half water tanks and half fuel tanks, and I'll be saving more than 5 carbon fiber masts.
Yeah, it is difficult. In the design sense, when we're optimizing something, we can run all these different iterations. So we can, say you have a race like a Transpac race, which is always done on one jibe, basically. And so you can look at optimizing for the specific wind conditions and heel angles and all these kind of things and trade these tiny things. In reality, when we're operating a cruising boat, we don't have a luxury of all those choices a lot of the time because we're constrained some other way. We need full tanks to leave Cape Town. You're not going to leave Cape Town with half tanks. But somewhere else you do have that choice. And it may be that that's a bigger performance choice than some other much more expensive looking item on your wish list.
So I think if you're sort of interpolating this from what Phil is saying is your launch weight, the boat is more buoyant. And as you put more stuff on it, obviously you're going to displace more. So
well, yeah. I mean, what I'm saying is that we've never built a light ship boat because nobody wants a light ship boat, right? Everybody gets what we call the Essential Voyager package. They're getting several sails, and they're getting air cons and 4 refrigerators and water makers and life rafts and all this stuff, which is not deemed light ship. And so I don't think those kinds of pullers are going to be very helpful to people in terms of predicting performance. And that Pat made the point that if people are actually engaged in attempting to find some scientific verification of what performance the boat's going to get, it's a challenge unless you can get all the builders to agree that they're going to produce their pullers either at full load displacement. What do you call it? Mid
half load
displacement, or light ship. Light ship, I think, is worthless, right, for a cruising boat. So it would either be half load or full displacement.
In the monohull world, we have more boats in a single racing handicap system. When you're trying to compare apples and oranges, you can go to a rule like ORC, and you can download certificates for different kinds of boats. And the boats are all then in a measurement configuration. So they're all in the same measurement configuration per the rule. And you can get them all basically rated by this same rating tool, the ORC racing rule. And so you can draw comparisons. In a cruising world, those boats don't make it into that library as frequently, so it's a little more difficult. And in the multi-hull world, that's, again, less typical. So the consumer trying to compare boats is in a difficult position where they don't have a lot of apples. And so it's difficult to draw good conclusions. And even as designers, when we're comparing boats that we didn't design with boats we did design, we are forced to drag as much of their information as possible into our VPP, reproduce it, and then we can draw apples and apples comparisons. And obviously a consumer can't do that.
In real world applications, how close is an average sailor getting to his polars? Actually not really reaching his absolute maximum performance polars.
And what displacement? Say midship displacement? Or?
Sure.
I think most people are running somewhere between midship and full displacement probably most of the time.
Yeah, but even if you had a VPP that was set up at those exact things, the average person's probably sailing around at less than 80% of their boat's performance. But it depends on the conditions, right? If you're in flat water, 12 knots of breeze, everybody gets closer to the VPP numbers there, right? And when conditions get more challenging, it gets harder and harder to get close to those numbers.
Mm-hmm. Absolutely, yeah. I mean, I've always think they're optimistic, very optimistic for most cruising sailors.
They are what they are, right? So they're an estimate, and they're based on the best tech you have available at that moment and the information you provided. And
Yeah. And of course, you know, in the performance catamaran space, the narrower boat, the more flat-sided boat, it has a higher sinkage ratio, so its performance is going to degrade as those numbers, as those displacement numbers go up. Okay, so the VPPs will start to separate. You know, boats would start to separate under load. You know, it was years ago. I used to represent a French company that built a boat called the Switch 51. I don't know if you remember those boats.
I do.
Yeah, I brought it to Annapolis in 2002 and sailed through a hurricane, by the way, to get there. That was an event. But the Switch 51 was competing at the time with a boat called an Outremer 53 or 55. The Outremers at the time were really kind of primitive. They were really long, solid fiberglass hulls. They were solid fiberglass hulls. So the boat was actually pretty heavy in a way, but it had all this waterline length. It was super narrow. So and so we were in these races against this Outremer. And what we found was that when those guys were cruising in the Caribbean, the Switch was faster because it was a foam core boat. It's actually volumetric. Fiberglass parts were lighter and it had much more volume. And so it actually was faster. But I think if the Outremer was buck naked, like an empty, then it was faster because it had that narrower hull fineness ratio. And that's an interesting, you know, thing. Like the performance can really, really degrade on a boat when you start adding stuff. But again, the more performance oriented the hull, or the sharper, the narrower it is, the more that weight really impacts that performance.
That wraps up our discussion on polars. In our next installment, we're going to get into sail inventories and sail plans.